In this video, we're going to take a look at section 1.3, which is on applications and problem solving. Now, our first objective is we're going to take a look at solving applied problems by translating to equations. Now, the strategy for solving applications is to first assign a variable to the unknown. And now, if you have more than one unknown in the problem, you'll assign a variable expression using that same variable as step 1. Step 3 is to translate the problem into an equation. And then step 4, you're going to solve that equation. And then step 5 at the end, you have to make sure that your answer makes sense. So sometimes you might be solving for time and you might end up with a negative answer. Well, we know that time cannot be negative, so that will require you to disregard that solution that you obtained. Also, if you're dealing with, say, like length, so if you're trying to find the length of, say, like a rectangle, we know that length cannot be negative. So, I mean, when have you ever measured something you came out with a negative length? So if that's the case, then you have to disregard that solution as well. Now let's take a look at our first example. So it says, from 2015 to 2016, Texas gained 432,957 residents. This was 13,451 fewer than 4 times the number of residents gained by North Carolina during the same period. How many residents did North Carolina gain? Okay, so first let's take a look at our unknown. What are we trying to figure out? So if we take a look at the last part of the example, it's asking how many residents did North Carolina gain? Okay, so this is our unknown. So let's let x be equal to residents North Carolina gained. And now let's take a look at any other information that was given to us. So it says from 2015 to 2016, Texas gained 432,957 residents. And then it's telling us this was 13,451 fewer than 4 times the number of residents gained by North Carolina. Okay. So first it's saying that Texas gained 432,957 residents. And then it's saying this was. So we have 432,957. And now this is a key word for equals. So 432,957 has to be equal to 13,451 fewer than 4 times the number of residents gained by North Carolina. Okay, so now we have to write this part out. 13,451 fewer than 4 times the residents gained by North Carolina. Now, a common mistake I see all the time is a lot of students will put 4x, so 4 times the number of residents gained by North Carolina, so that indicates 4x. And they'll put 13,451 minus this number. So just be careful because it's saying that this is 13,451 fewer than 4 times the number of residents by North Carolina. So that indicates that we have 4x and then minus. So this is 4 times the number of residents gained by North Carolina. And then it says 13,451 fewer than that. So it's going to be 4x minus 13,451. So now we have our equation set up. Now we're going to go ahead and solve. Okay, so we want to solve for x. So going back to our strategy from section 1.1, we're going to go ahead and add 13,451 to both sides. Okay, so let's go ahead and add those with each other. So 432,957 plus 13,451. Okay, that gives us 446,408, and we have equal to 4x. And now last step to solve for x is to go ahead and divide by 4. So we have x is equal to, so we get 111,602. So the amount of residents North Carolina gained was 111,602 residents. Let's take a look at another example. Now for this example, it's saying in a triangular cross section of a roof, the second angle is twice as large as the first angle. And then it says the third angle is 20 degrees greater than the first angle. Find the measures of all angles. Okay, so over here we're dealing with the triangle. Now when we're dealing with the triangle, we have three angles. And now one important property that we need to know for triangles is all the angles, when you add them together, has to be equal to 180. So the sum of all angles in a triangle equals 180 degrees. Okay. Now in this particular problem we have three unknowns. We have the first angle, we have the second angle, we have the third angle. Okay, so we have first angle, second angle, and we have the third angle. Okay, so one of these unknowns we're going to assign the variable x, and then the other two unknowns we have to write out a variable expression containing x. Now if you take a look at this problem, it's telling us that the second angle is twice as large as the first, and it's also telling us that the third angle is 20 degrees greater than the first. So the second angle and the third angle, these are both being compared to that first angle. So what we could do is we let that first angle be x, and now we could write out an expression for the other two unknowns, for the second angle and the third angle. Well, it says the second angle is twice as large as the first angle. So if our first angle is x, that means our second angle has to be 2x. That would be twice as large as the first one. Then we're given that the third angle is 20 degrees greater than the first angle. Well, if our first angle is x, then 20 degrees greater than it would be x plus 20. So we have expressions for all of our unknowns. Now we have to write out an equation. And now this is when we use the property that the sum of all angles in a triangle is equal to 180 degrees. So that means when I add up all these angles, it has to be equal to 180. So I have the first angle, which is x, plus, now the second angle, which is 2x, plus, and then the third angle, which is x plus 20. This has to be equal to 180. Now the hardest part for these word problems is setting up this equation. Once you set up the equation, you use the same strategy as section 1.1. Okay, so let's take a look. I notice on the left hand side I have some like terms I could combine. So x plus 2x plus x, that gives us 4x. And we have plus 20 is equal to 180. So let's continue to solve for x. Subtract 20 from both sides. We get 4x is equal to 160. Let's go up here. So we have 4x is equal to 160. Now last step to solve for x, we go ahead and divide by 4. We get x is equal to 40. Okay. Now x, this just represents the first angle. So now we still have to figure out what our second angle is and what our third angle is. So what we have to do is go ahead and plug in our x into our expressions over here. And then we can figure out what our second angle is and what our third angle is. Okay, so we know our first angle is 40 degrees. Our second angle has to be 2 times x. Well, we figured out that x is 40. So we have 2 times 40, which gives us 80. So our second angle is 80 degrees. And then for our third angle, replace x with 40. So we have 40 plus 20. This will be equal to 60 degrees. So first angle is 40, second angle is 80, and then the third angle is 60. And then a quick check. So remember our property, all the angles have to equal 180. So the 40 plus 80, that gives us 120. 120 plus 60, that gives us 180. Let's take a look at a different type of problem. Okay. In this example, it states, Acton Sporting Goods lowers the price of a pair of cross-training shoes 20% to a sale price of $68. What was the original price? Okay. So in this problem, we have one unknown, which is the original price. So let's let x be equal to the original price. So another thing to notice in this problem is we're getting a discount. So it's saying Acton Sporting Goods lowers the price of a pair of cross-training shoes 20% to a sale price of $68. Okay. So X is the original price of the shoe, and then we're getting 20% off. So in order for us to figure out what 20% off of the original price is, you have to multiply X by 20%. But just be careful whenever you're multiplying or doing anything with decimals or with percentages, you have to change it into a decimal. So 20% as a decimal, this would be 0.20. So now we have the original price, so we can set up our equation. We have X, and now since we're getting a discount, we're going to have minus, and then 20% off the original price, so this would be 0.20x. This has to be equal to the sale price of 68. Okay, now what this expression tells us right over here, this tells us the actual amount of money we're getting off of the shoe. So that would be 20% of the original price. And our original price, we have a variable of x. So now let's go ahead and solve this equation. So you could do this a couple ways. If we follow our strategy from section 1.1, we could eliminate the decimals. So if I want to eliminate the decimals here, I can multiply by 10. Since 0.20, this is just the same thing as 0.2. So let's go ahead, let's just change this to 0.2x. So now I'm going to multiply each term here by 10. So I have 10x minus 2x is equal to 680. Now I can go ahead and combine like terms. So the 10x minus 2x, I get 8x equals 680. Now we can go ahead and divide both sides by 8. So we had x is equal to, now 680 divided by 8. Let's take a look and see what that gives us. We get 85. So the original price of the shoe was $85. So if you take 20% off of this, the sale price will be $68. Okay, next example, this one's a little bit different. So it says, an artist creates 500 prints and saves 3 for her children. The numbers of those prints are consecutive integers, whose sum is 1,266. Find the numbers. Okay, so we're given that these 3 numbers are consecutive integers. Consecutive integers, what that means is one right after the other. So for example, 5, 6, 7. Now, we don't know what the first integer is. Okay. Otherwise, we could just add 1 to it. That'll give us the next one, and then add 1 to it. That'll give us the other one. So since we don't know what the first one is, you're going to let your first integer be x. Now, in order to get to the next consecutive integer, so for example, how do I get from 5 to 6? I had to add 1 to it. So that means my second consecutive integer would be x plus 1. And then how do I get to my third one? So remember, we're referencing our first integer. So how do I get from 7? How do I get from 5 to 7? I added 2. So our third integer would be x plus 2. So this is 3 consecutive integers. Now you might see a different variation of this type of problem where it says 3 consecutive even integers. If it said 3 consecutive even integers, that would indicate, say, something like 8, 10, 12. Well, you'll still let your first integer be x, but now to get to the next even integer, you have to add 2. And then in order to get to the third one, you'd have to add 4. Okay. Now if you had odd, say 7, 9, 11, your setup will still be the same. Your first integer would be x. Then to get to the next odd integer, you still have to add 2 to that. So your second odd integer would be x plus 2, and the third odd integer would be x plus 4. Now for our particular problem, we were just given that it was 3 consecutive integers. And it's saying that the sum of those integers is 1266. So when I add up these 3 integers, it has to be equal to 1266. So I have x plus 1 plus x plus 2. This has to be equal to 1266. So this is our first integer, this would be our second integer, and then this one was our third integer. Now that we have our equation set up, let's go ahead and solve the equation. We could begin by combining like terms. So on the left hand side, x plus x plus x, that gives us 3x. 1 plus 2 gives us 3. We have equal to 1266. Now let's get our x by itself, so subtract 3 from both sides. We get 3x is equal to, we get 1263. Now last step to solve for x, we get x is equal to, so dividing this out, we get 421. Okay, so that just gives us the first integer. So 421 is the first integer. Then the next consecutive integer would be 422, and then you have 423. And now we have our solution. Now our next objective, we're going to take a look at basic motion problems. So we have a formula for motion. It's distance is equal to rate times time. So we have d is equal to r times t. So we're going to be using this formula for this next example. Okay. So we're given Tim's fishing boat travels 12 kilometers per hour in still water. So what it means in still water is that there is no current. Okay. So if there's no current, this boat travels 12 kilometers per hour. Now it's asking how long will it take him to travel 25 kilometers upstream if the river's current is 3 kilometers per hour. And then also 25 kilometers downstream if the river's current is 3 kilometers per hour. Okay, so we have two separate questions here. So we have upstream, when the boat's going upstream, and then when the boat's going downstream. So we have distance is equal to rate times time. Okay. First thing we have to do is we have to figure out the rate of the boat. Okay, now if we're going upstream, what that is indicating is the current is hurting our speed. The current's like pushing against the boat. So our rate, so we have to account for that for our rate. So in still water, the boat travels 12 kilometers per hour. Now since it's going upstream, it's hurting our speed. we're going to subtract the speed of the current. So the rate of this boat going upstream is 9 kilometers per hour. Okay. Now, one other piece of information that we're given here is the distance. So it's asking us how long will it take to travel 25 kilometers. So our distance here is 25. We have equal to our rate, which is 9. And then t is what we're trying to solve for. We're trying to figure out how long is this going to take. So we want to solve for t. We have our equation set up. So to get t by itself, we're going to go ahead and divide by 9. We get t is equal to 25 over 9. And our units here would be hours. But this doesn't really tell us how long it took. So if you're talking to somebody, you would never say, it took me 25 over 9 hours. Okay, so let's go ahead and simplify this. Okay, so we can see how many hours it is. So 25 divided by 9. So ask yourself, how many times did 9 go into 25, which is twice. That should give you 18. And then how much is left over would be 7. So you have 2 and 7/9 hours. Okay. And then another thing that you could do is you could change the 7/9 into minutes if you'd like. So 7/9, if you want to change that into minutes, okay, so you're going to have 7/9 times, and then how many minutes are an hour, which is 60. Okay, so you're going to multiply this out and see what we get. So 7 times 60 and then divided by 9. That gives us about 47 minutes. So about So this gives us 46.6, and this just keeps repeating. So we have 2 hours, 47 minutes. So this was if the current was, if the boat was going upstream. Now if it's going downstream, okay, so we're still going to be using the d is equal to r times t, but now our rate's going to be a little bit different. Now since we're going downstream, this time the current is helping our speed out. So the rate of the boat going downstream would be the 12 kilometers it goes in still water, plus the speed of the current. So we have a rate of 15 kilometers per hour. Okay. Now let's plug it into our formula. So we're going to have 25 is equal to, now our rate, which is 15, and then time is what we're trying to solve for. Okay, now go ahead, divide both sides by 15. Okay, so we get t is equal to 25 over 15 hours. Okay, and now let's go ahead and simplify this a little bit. So 25 over 15, I could simplify this fraction first. 5 goes into both of these, so I get 5 over 3. So I have 5 over 3 hours. But once again, we don't really know how many hours that is. So change it into an improper, or change it into a mixed number. 3 goes into 5 once, and there's 2 left over. So we have 1 2/3 hours. Okay. And now we could change the 2/3 to minutes. So we have 1 hour, and now 2/3 of an hour. So 1/3 would be 20 minutes. So 2/3 would be 40 minutes. So we have 1 hour, 40 minutes. Okay. Now that was it for this section. Just remember, if you have any questions, just feel free to email me, and then I'll be happy to go over any part of it.